Hey there, ladies and gentlemen. We're going to go ahead and just review your 8-4 notes from last week, the part 1. So let's just talk about this. If you didn't go through this on Friday, then it's going to be good and fill your notes in. If you did go through each of these notes, it's fine. It's just going to be a good review. So I especially want to focus on this first part where we are looking at irregular regions, because that seems to be there was like the most confusion. So it says, what do you estimate the area of this region to be given each square is 5 feet in length? So you kind of can go through this and decide how you want to estimate it for this first one, but as you know, we kind of talked about on Friday, or you kind of talked about on Friday, you're going to count the full squares and you're going to count the partial squares and divide them by 2. So I'm going to go through and I'm going to put a little red X in anything I consider a full square. You and I might disagree, like on this one here. I'm going to call that a full square. You might not call it a full square. That's fine. Actually, maybe I won't call that a full square, looking at something else. So I'm going to call these full squares. So I'm just going through and putting an X on anything that I think looks like a full square. And then I'm going to count them up. All right, I'm going to count these ones as full squares too. I know that the border goes like really close on it, but I'm just going to count them. So let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So I have 30 full squares. Now, if I did this tomorrow, maybe I would disagree and I'd have a little bit different, and that's okay. Okay, now I'm going to go put an X on anything that I think is a partial square. So the reason why I changed my mind on this one is because I'm going to count this as a partial square, and if you look, those two together almost make a full square. Okay, so I'm going to, most of it is just the border that I'm putting X's on for my partial squares. And then I'm going to go around and count them off, and I'm going to add them up. So I'm going to start here. So 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15, 16, 17. All right, so I have 17 partial squares. And then we had to divide that in half, so that gives me 8.5. So now what I do is I go and I add my full squares to half my partial squares. So 30 plus 8.5, and I get 38.5. And then I times it by the area of 1 square. So it says 1 square has 5 feet in length. So that means this is 5 feet and this is 5 feet. So if I find the area of that, that's an area of 25 feet squared. So now I'm going to go ahead and take my squares and I'm going to times it by my area. And let me go ahead and grab a calculator and do that. 25 times 38.5, we get 962.5 feet squared. All right, so go ahead on your note sheets and pause the video here so you guys can all write this down in on your note sheets. All right, hopefully you would pause that. So if we go ahead and do this, find the area of the lake below. Each square is 2 miles in length. So I'm just going to do this right off the bat. If it's 2 miles in length, this is 2, this is 2. So my area is 4 miles squared. Okay, so that's for 1 square. So now I'm going to pause the video. I'm going to go through and count the full squares, and then I'm going to count the partial squares and divide by 2. Please pause the video here and do that if you haven't done so yet. All right, so I went through and I counted 28 full squares in red and 24 partial. Again, if yours is just ever so different than mine, that's fine because you and I might have just disagreed about it, and that's, I'm not looking for an exact thing here. We're going to be off slightly. It's inevitable that there's going to be at least one problem that you and I have different answers. Okay, so I took my partial and I divided by 2 and I added that to my full amount. So 28 plus 12 gave me 40. And then I times that by the area of 1 square, so I get 160 miles squared. All right, another one like that. Here it says that my finding the area of the lake, each side is 0.25. So right off the bat, I'm going to take 0.25 and I'm going to square it. So my area is 0.0625 miles squared. All right, so pause the video here and I want you to go through and count full boxes and partial boxes and then complete the rest of this problem so we can double check. All right, so this one definitely a little bit harder, I think, in my opinion, on what's a full and what's a partial. Now, if you look at my partials, I didn't count this one as a partial. You maybe did. Same here. There's this one. I mean, there's really, I could have gone totally gone with like 14 up to 16 probably partials. Anyways, so this is where I'm at with this one. If you counted some of those purple boxes as partials, you might be increased slightly from this. All right. So hopefully that clarified some during your confusion on irregular area. If you guys as a class feel confident about a composite area, you don't have to watch the rest of the video. If you're not feeling so confident, I'm going to go ahead and do some on the back and you can watch it, watch some of it, get what you need out of it. All right, composite figure. It's a figure that can be separated into regions that are basic geometric shapes. So here's an example there. So we start here and I tell you what I want you to break it up to, a semicircle and a trapezoid. So we are in need for the semicircle, finding our radius and diameter, and that we can transfer over here into the height because we need the height for the trapezoid also. So if I check that, this distance here is 22. So that makes this a distance of 9. So I'm going to use my right triangle here to solve for the height of my trapezoid, which is also the diameter of my semicircle. So hopefully you'll find that that is 12. So that makes it have a radius of 6. So now it's all broken down for you. Find the area of the semicircle. Semicircle, remember, half a circle, so pi r squared, and I'm going to divide it by 2. So I'm going to take pi times 6 squared, and then I'm going to divide that by 2. So go ahead and do that in your calculator if you haven't. You get 56.5 centimeters squared. Then area of our trapezoid, remember from 8.2, trapezoid is height times base 1 plus base 2 divided by 2. So my height was 12 times my base 1 of 22 plus my base 2 of 31. All of that divided by 2. So go ahead and put that into your calculator. And we get 318 centimeters squared. And then for the total area, you're just going to add the two areas that you have there. And you end up with 374.5 centimeters squared. All right, let's look at the next one here. It says to break it down into a semicircle, a triangle, and a rectangle, and that's kind of already done for us here. So the semicircle, they give me my radius, so I can go right ahead and do pi times my radius squared, and I'm going to divide that by 2. So we get 25.1 feet squared. Now, when we look at this triangle, they give us a base and they give us the 5.7. We're missing the height here. It might be the same as the radius, but it might not. So we just want to double check by using Pythagorean theorem. So height squared plus 4 squared equals 5.7 squared. So go ahead and solve that in your calculator, please. All right, and so you actually end up with a height of 4.1, so just ever so slightly off. So area formula for a triangle is base times height, divide by 2. So 4 times 4.1, divide by 2. And you end up with 8.2 feet squared. And then area of this rectangle, we have 4 times 7. So that one's an easy one of 28 feet squared. And then you're just going to go ahead and add those three all together to find your total area of the figure. 61.3 feet squared. All right, so those ones are really nice, those first two, because they broke it down for you. Now it says find the area of this figure below, and it's not broken apart for us, but we can go ahead and do that. So multiple ways to break it apart, and I'll just show you some. You can drop this down in this, so you have two rectangles and a triangle. You could go ahead here, and now you have a trapezoid and a rectangle. That's actually different than how I did it on the notes, but I actually want to do it this way because to me, this seems like they already give me all the information and it's a little bit shorter. So area of the trapezoid, I'm going to take, I got to find my height. So if this is 5, and the whole length on the left says 12, so 12 minus 5, this is 7. So my height is 7 times base 1 plus base 2 divided by 2. So grabbing my calculator, and I'm going to go ahead and do that. All right, I got 80.5. And then my rectangle, I'm just going to take 5 times 15, and you go ahead, and that's 75. So now I'm going to go ahead and add those two together, and you get 155.5 inches squared. And that's exactly the same thing I got when I broke it apart into two rectangles and a triangle. But I would say break it into the least amount of shapes that you need, because that makes it a little easier. All right, so then here it says find the area of the shaded region below. So to find the area of the shaded region, we're going to find the area of the whole rectangle, the big rectangle, and we're going to subtract out the area of the small one. Now in the big rectangle, we don't get our length and width, but we can go ahead and find those. This part here is 25 plus 100, and then we're going, the frame has 25 width on all sides, so this is another 25. So that gives us 150. And then here we have a 25 plus 20 plus a 25. So that gives us 70 here. So for my big rectangle, I'm going to take 150 times 70. And I'm going to minus out my small rectangle, so 20 times 100. Go ahead and grab your calculators for this. Type that in. You could type it all into one, and it should work out just fine for you. And the shaded region is 8,500 feet squared. All right, so hopefully this helped clear up anything from Friday. Please go ahead and fix your assignment if need be, and then I want you to grade it as a class, and then there's some more things that I have for you guys to do. All right, hope to be back tomorrow. See you guys.